Now, here we go. As some of you know, my name is Conal Doyle. I am a senior pre-sales engineer with KX. I'm going to talk about KDB-X for the next 15 minutes. It's kind of ridiculous having two microphones, so I'll probably go back to one, or do you want to go back? Go back to one. I'll kick us off with a video because we've talked about the installation process, and I just wanted to kind of give you a flavor of how easy that actually is. You don't even really need to watch the contents of the video. It's pretty self-explanatory. You're just Googling KDB-X and following the steps through to completion. My beautiful assistant is me from the office a few days ago. But what I wanted to kind of share was that I've been with the company for 11 years in some capacity or another, starting off as a financial consultant, moving on to be a software developer, a KDB developer, and then finally transitioning into sales engineering and standing here on the stage right now. This is going to be cliche, but this is honestly the most excited I've been by the direction of KX since I joined in 2014. And it's fair to say that KDB-X is the spearhead of that optimism. And now that we're up and running, let's dive into what it actually is. So KDB-X is the next generation of KDB+. It comes with it's based on three fundamental pillars: accessibility, extensibility, and interoperability. And it comes as a layered package, so something similar to an onion, I suppose. And at the core of the package is a programmable engine with a Q runtime, Python integration, open data formats, and support for open data formats, and module framework. Q runtime being important, obviously, because it means it's backwards compatible with KDB+. On top of that are DB services, enabling efficient abstracted access to real-time and historical data, both structured and unstructured. Further to that, there's connectivity for sources and sinks, and custom feed handlers for capital markets. This layer greatly enhanced by our recent merger with OneTick, who bring outstanding capabilities and knowledge in the world of data collection. Our dashboards are getting a revamp with a natural language experience being brought to them, and that's part of a larger overall push to ensure that the platform is AI native. So it will come with built-in AI capabilities for structured and unstructured data, as well as specialized GPU accelerated primitives that Nataraj is going to talk through after my demo, which is really exciting, and I think you'll enjoy that. In terms of what's in the public preview right now, the capabilities, I touched on it earlier, but it's backwards compatible with KDB+, so you can reuse your KDB+ and Q code. It offers a unified data stack, so I think we've always been proud of the fact that our solution sits across the entire data pipeline, but now you can bring unstructured data into the fold as well, which is quite exciting, obviously. We've developed a class of functionality, AI libraries, for you to be able to analyze structured and unstructured data together. We've built out a developer center. Ryan touched on this earlier. So that's a one-stop shop for all developer resources. We continue to develop our interoperability with Python and SQL, ensuring that those integrations are as tight as possible and work is ongoing on those integrations. And finally, we have developed an MCP server, which is a natural language interface to KDB-X, and that's important to us because it opens up the technology to a less technical class of people, enabling those users to actually derive value from the KX platform where they couldn't before. Great ringtone. And let's actually take a look at the MCP server. I have a demo here of us using it. So You can use any MCP client you want. Here we're using Claude to connect to a backend MCP server, which in turn connects to an underlying KDB-X database. We've developed certain tooling and functionality that you can use to query the database through the MCP client. First thing we're doing is describing the tables that actually exist within the KDB database. All of this tooling is built in SQL. And then through natural language, we can ask for the highest price looking at commodities data, and it'll return us the highest price by commodity. What's nice is you can double click into the queries and just double check they're actually running what you're expecting them to run. That's obviously the structured component. Now we can integrate the unstructured component. So we're looking for associated news with the highest, with the times the price for the commodities data was highest. And this unstructured data is not coming off the internet. This is coming from the KDB-X document store, which you can search using SQL, or else you can search using vector embeddings and a similarity search. And then finally, I've just asked Claude to kind of put this all together and give me something neat that's digestible by humans. And you can see that it puts together this nice little nifty timeline marrying structured and unstructured data. So that's quite cool. Okay, so that's everything that's in the product right now in the public preview. Let's talk about what's going to come by GA. So it's going to come with module management, the ability to create, share, and reuse code via modules. It will come with support for open file formats, starting with Parquet, but with others to follow. And it will also come with the functionality we've built out for Insights Core, namely modules for curl, object storage, PGWire, and REST. So modules, what are they exactly? They are the key to our extensibility feature, our extensibility pillar within KDB-X, should I say. And what will they look like at GA? Well, at GA, they'll bring core language improvements. So they'll unify namespace and library concepts to deliver structured, reusable code. New Q primitives will be available to modernize library handling, similar to Python. Loading and creating and supporting libraries developed by KDB-X will be simplified. In terms of product and developer impact, modules will boost app development through reusables and standard modular components. They will accelerate team productivity by making it easier to build and to share solutions. And eventually all KX products will evolve to leverage this module framework. In terms of the ecosystem, we hope modules will enable the wider community to contribute and consume from the KDB-X ecosystem. It will encourage partners, hopefully, and users to refactor larger frameworks like Torque or Phenos into modular published libraries, and will help new teams on board with high-quality repository for real-world tasks. Modules will have certain properties in KDB-X, so we've defined a module to be a unit of code loading. Every module will have its own file path. They'll be both isolated and portable, in mem and on disk. They can be written in Q, K, or C extensions. Every module has an export key or a dictionary defining its public interface. And finally, every module has its own private namespace. So let's take a look at what that actually looks like in KDB-X. I'll start off by looking at QHome, which in KDB-X is defined as .kx by default, but you can change that. You can see there's a mod directory underneath .kx, and underneath mod, there's a KX directory. The reason being is that certain modules will be developed and maintained by KX, but you can set your own modules alongside them. If you look underneath these directories, you can see that it's composed of either Q files, shared object files or C files, and K files. Firing up a Q process next, we can use one of the new primitives to load in the module. The primitive is actually called use. So we're loading in the AI module. This is the public interface, the dictionary that's available, the functionality that's available once you load it in. You can assign that to a variable, AI. And then finally, if you look at .z.m, you can see it has its own private namespace within the process. So that's one exciting feature that's coming at GA. The next is Parquet. So at GA, we will provide native Q, QSQL, PyKX, and SQL support for Parquet. There will be default data type conversion and null handling. There will be support for external compression libraries, namely Zappy and ZSTD. And there will be support for role groups and Parquet metadata. We will introduce the concept of a virtual table. So that will be a universal table interface that will allow the redefinition of the underlying select exec support for Parquet datasets. Supports implementing your own database partitioning layouts, so you'll be able to lay the data out in different partitioning layouts. Partition filters can appear anywhere in the query and take advantage of MapReduce. And then, as I mentioned earlier, Parquet is just the first step. Next up, we're looking at integrations with Iceberg and open table formats to take advantage of object storage properties, and also virtual tables for KDB native database format. Again, I think it's beneficial to see this in KDB, but first, just to reiterate, the virtual table interface will support Hive partitioning. So let's take a look at what that actually looks like in KDB-X. Oh, sorry. So here I'm looking at foreign exchange tick data, 252 Aussie dollar files, all in Parquet, one file corresponding to a month for the previous 20 years. I've taken the liberty of downloading and unzipping it, and this is what it looks like on disk, one Parquet file per month for 20 years. Fire up the queue process. And we will construct a table of the file paths to all those Parquet files. I'm going to show you two examples. I'll show you one example where I'm reading a singular month in, so a singular file path. The table of files is type 98H, standard KDB plus table type. What I'll do next is use our modules, our Parquet module, to import the functionality I need to create these virtual tables. Looking at the functionality is locked, so it doesn't stop it from doing what it's meant to do, but I can't see it now. There will be documentation, obviously, with all these modules to figure out what they're actually doing, but long story short, using this Parquet functionality, I can create a virtual table called fxquote. And once I've created this virtual table, I can perform standard QSQL operations on it. So selecting count I from fxquote, and then looking at like bid, ask, price, and volume. The next example I'll show is going to be multi-file. So I am going to create a composite virtual table using the 252 Parquet files on disk. So let's look at our files table again. I remember it's a table of all the file paths, 252 file paths. Again, using the module framework, I'm going to load functionality in that allows me to create this composite virtual table. These are all K functions, as you can see. So I've created something called PQTab, which is effectively an array of virtual tables. And you can see what this looks like in process. So effectively what I'm doing now is I'm going to do something that's similar to arrays. I'm going to use the functionality I got from pq.t, and I'm going to make a composite virtual table called fxquoteAll. And once I've used fxquoteAll, or once I've built it, which is not type 98, by the way, this table is not in memory. This is a virtual table, not dissimilar to a partition table in KDB+. And again, you can just perform QSQL operations on it. So selecting row counts by total, and then by file, and then finally, I think I pulled the max bid ask by month for the first 6 months of 2024.